All right, I'm going to actually press pause on you working. I want to go through, Malky, is this blue? Okay. I want to go through what your homework is for tonight because I do have to change it. I'm going to actually cut it a little short. I forgot that I didn't put in an assignment for 3.81, which is where we are. We're not in 3.8.2 yet. So you're going to finish 19, which has 2 more of these type problems, and I'll give you a really small set from number 20 that has to deal with what we do today. You can't do the rest of 20 because it's a bunch of new derivative rules that I haven't given you yet. All right, so today's warm-up is also reviewed. This is similar to what I could give you on the quiz tomorrow, okay? But with the right amount of time, you would have 15 minutes total, so you would have had another 4 minutes to finish, okay? What I want you to do is grade it. Oopsie. All right, so here is the problem. We're going to go through grading it. This is what a scoring rubric looks like for the AP. They essentially tell you how you get your points. So right now, you're going to look at your question. Look at part A. Give yourself 1 point if you took derivatives and you used dy dx in it. Okay, give yourself 1 point. I want you to put a +1 just like that next to it. If you actually did get the first derivative in part A and you didn't cheat and just rewrite it, you actually did the work, give yourself a point. Okay? Part B, the reason why they tell you what the derivative is, they don't want you to get everything else wrong, so you just have to show that you can get there. Part B, give yourself 1 point if you ended up with y squared minus y equals 6. Give yourself a point if you get y equals 3 and y equals -2. Give yourself a point for each of the tangent lines. One of them simplifies to y equal to 3 because the point is 1, 3. The derivative is 0 at that point. And then the other one is y plus 2 is equal to 2 times x minus 1. The point is 1, -2. 1 point here and 1 point here. So far that is a total of 6. I think that's as far as most groups got. I am going to show you the points for the next piece. If you didn't have enough time to do it, don't write down the answer. I would tell you to try the problem on your own tonight, and the key will be up. For those of you that got there, 1 point for setting the denominator equal to 0. 1 point for solving it for y or x. You could have done x, not a good idea though, because you have a plus or minus root. And then you get 1 point for the answer, which is the 5th root of -24. That is the final answer for part C. If you finished it, you can total yourself out of 9. There's 9 points total you could have gotten. What I would say is don't read the answer right now. I would try it at home tonight and then give yourself a score out of 9. It gives you a good idea of if you're doing well. A good AP score is 7. Out of all the questions we do, if you can consistently keep getting 7s, that's actually really good. 7s on every single one or above, essentially you're guaranteed a 5. Okay, 7's your goal. 8, of course, is awesome. 9 is beautiful, but 7's the goal. Okay? All right, so going back to A and B, because those are the only parts I think the whole class got to. Were there any questions real quick? Any part that you got stuck with? I will tell you what most people do wrong here in part B. It said when x equal to 1. Did anyone substitute it incorrectly in the beginning before someone corrected them? Oh, you liars. Everyone does it. Put it into the derivative and not into the function. Yeah. It happens. Oh, you're not the only one. Everyone else is just lying. All right? Be careful. It tells you x equal to 1 on the curve. And then if you read above, it actually says the curve is. So it gives you that little hint. Okay? All right. I am going to move on to notes because I want to get through a little bit more than we got through in the other period. So I am going to record it in case you miss a piece. All right? So 3.8. I would like you to go to 3.8, which should be, I think, the next page. All right? So right now at your tables, I want you to, if you know anything about an inverse, talk to your table about the only things you know about an inverse, and then we'll go through all of them. Alrighties. I am pretty sure I heard at least a few different things. Ty, what did your group say? One thing. Okay. Notation, this would be F's inverse. Good. All right. Lottie's group, you guys say anything? Anyone at the table? Esma? Inverse reciprocal. Inverse negative reciprocal. Just negative reciprocal. That wouldn't be an inverse, that would be a perpendicular slope, is what you're thinking. Okay? Perpendicular slope is what you're thinking. Next group back there, did you guys think of anything to add? 1 over the function is not an inverse. That's that tricky thing we always talk about. What is 1 over the same as? What's the word? Reciprocal. Reciprocal and inverse are not the same thing at all. A reciprocal means flip the fraction. That is what 1 over is. So I'll show you what an inverse is. If you want to find the inverse, that's the first thing I'm going to do, is how do you find an inverse? You find an inverse by switching x and y, then solve for y. That's how you find an inverse. I would actually write there, to find an inverse, ... I'm saving a little room for myself. Second thing that you should know about an inverse. How do you know what the inverse looks like on a graph? How do you know what an inverse looks like on a graph? First of all, without me writing it, it's where every single point, the x's and y's are switched. Every single point. If it's 2, 4, then it's 4, 2. If it's negative 1, comma 2, then now it's 2, comma negative 1. We switch the x and y's just like I said in number 1. Graphically speaking, they are reflections across the line y equal to x. Thought I was going to sneeze, but it went away. There it is. There it is. Woo. All right. Number 3. All right, let's see. Switching. There's something I'm missing here, and now that I'm sneezing, I can't remember where I was. There's a third thing. Graphically, function notation. Inverses, they will be inverses of each other if you take the composition of the two functions. If you think f and g are inverses, when you take the composition, it should be x. There's a big and right here. I'm going to run out of space. And the other way around, g of f of x is also x. Has nothing to do with derivatives. This is all review. All right? So those are just rules. That's everything that you should know about an inverse up to now. So now we're going to play around with this function here. Find the function's inverse g of x. So in step 1, it tells you how to do it. This would be switch your x and y and solve, oopsie, that's supposed to say y, and solve for y. So do that first, please. This guy's going to have to come off. Alright, let's double check with me. X plus 2 is equal to 2y squared. I'm going to do this all in one step. Y is equal to, double check you have a plus or minus. Double check you have a big old root. If I divide these by 2, I'm not going to do one big fraction. I'm just going to divide both of them by 2 instead. It makes later on when we take a derivative a little easier. So let's try to figure out why there's a plus or minus. Why are there 2? Because when we graph it, you'll notice. All right? So this function, I'm going to factor it so I can graph it a little bit easier. I think it's... So you factor out the 2, you get x squared minus 1, so I factored that also. Okay? Is everyone good? So what does that give me that's easy to graph? Why would I want it factored? The intercepts. So the intercepts are 1 and negative 1. What's another x value that's easy to find the y value for? 0. If I substitute in 0, I get negative 2. And in the other class, I did this really quickly, and they couldn't figure out how I knew to do this fast. If you understand your transformations really well, this is a vertical stretch of 2. Most parabolas, the regular parabola, goes over 1, up 1, over 2, up 4. That's how parabolas, x squared parabola is done. Well, I'm stretching it by 2. So what does that do? Instead of going over 1, up 1, you stretched it to over 1, up 2. Instead of over 2, up 4, if I stretch it by 2, it means double that. So how high will I get? Instead of over 2 up 4, I'll actually go up 8 total. That's how I knew that that was the point really fast. I graphed it too quickly for the other class. They got themselves all confused, their panties in a bunch, and couldn't figure out why. All right? So I used the transformation. What could you have done? Substitute in 2. Substitute in -2. You'll get the same answer. All right. So here is my function. I am going to graph it with 2 colors. Okay? The left side of the graph I'm going to do in like a red color. And then the right side of the graph I'll do in purple. And that's just to show you why there's a plus or minus. You don't have to use 2 colors if you don't want to. We're going to graph the inverse really fast, okay? Because if I asked you to graph this, I don't think it would happen very quickly. So what's the easiest way? Go back to step 1, switch your x's and y's. So instead of 0, -2, I would graph -2, comma, 0. So on this red side, I'm going to go in red also. Instead of -1, 0, I'm going to do 0, -1. Instead of -2, 6, I'm going to do 6, -2. Can you kind of ignore the purple and look only at the red here and the red here? Can you guys see that there would be a reflection across the line y equal to x, which is this yellow line? You see that this kind of cuts halfway through? Okay? So they are reflections across that line. And then the purple side I'm going to do in purple also. So instead of, where am I? 1, 0, I would go 1, 0, 0, 1, I mean. Instead of 2, 6, I'll do 6, 2. Oopsie, kind of missed it, huh? All right, so why did I do the 2 colors? It's because the original function is not 1-to-1. What does that mean? It passes the horizontal line test, but it does not pass the vertical line test. Okay? Right? Yes. I made that plus or minus because I had to take the square root of both sides. So when you take an even root of both sides, yes, you make the plus or minus. Okay? Yep. That's why we needed it, because you wouldn't have had the whole inverse. The inverse is not a function. That's because the original function wasn't 1-to-1. That's how that happens. Okay? So if I ask you about points on the red side, then I'm going to use the minus square root. If I ask you about points on the purple side, then the inverse, I'm going to use the positive. There's a plus or minus because it's not a function, so I have to know which side to use. Does that make sense to everyone? The purple side, those y values are all positive. That's why it's the plus. The red side, the y values are all negative, and that's why this is the minus. Okay? Just a little bit of things to know. Graph them all. All right, we're going to do part C, but we're going to do a few of them, so kind of write small. I've noticed that I liked this way a little bit better. Okay, so given that you have f of x, and that was 2x squared minus 2, we have g of x, which is plus or minus the square root of 1/2 x plus 1. I would like for you to find, first, f of 2, which we knew, right? F of 2 was 6. Without using the function up there, what is g of 6? 2, because they switch, right? So I haven't actually used g of x yet. Now, I want you to find f prime of 2, and I want you to find g prime of 6. And you'll have to do a little work with that derivative. Yes, it's a chain rule. Go ahead at your tables real quickly. So you are on part C. You are on part C, but we're actually going to do a little bit more with it than what it says. What was that again? There are 2 values. I'm using that value because it is the inverse point of this. 2,6's inverse is 6,2. I'm using the right side, so I'm using the purple side, so I have to use the purple side of the g function. Does that make sense? So if it helps you out, I'll even highlight. I ended up only using the plus side. If I use -2, that's why. Yeah, I didn't even substitute it in. F derivative 4x, we're good? Right? Hello? I think we're good, right? Please don't tell me that you don't remember how to do that. Oh, Lord. Okay, chain rule, double check. You should have a 1/2 power in the front. The inside's still the same to the -1/2 power, and then you should have another 1/2 because of the derivative of the inside. Now, I want to substitute in 6, but do you see this? Your mind probably doesn't really understand exactly what that says, so we're going to rewrite it. I don't want a negative exponent. So, if this whole piece is going to move downstairs, what's the only value in the numerator? 1, because there's this one times this one, which makes 1. What's the constant number in the denominator? 4. And then this root, because it's a 1/2 power, is now downstairs, and that's how I can write it. That is easier for you guys to substitute 6 into than to leave it as a negative exponent. Guaranteed. So now we're going to put 6 in. G primed of 6. All right, half of 6 is 3. 3 plus 1 is 4. The square root of 4 is 2. 2 times 4 is, and then we get 1/8. What was f prime of 2? 8. All right. Interesting. Just think about it. Second thing, we're going to try another one. I want you to find me f primed of, let's do 1. So pretty much same exact setup. F of x was 2x squared minus 2. What was the y value? Let's put that here because we did it in that order before. What is f of 1? 0. Therefore, what is g of 0? 1, right? They switch. Okay. Find me f primed of 1. Find me g primed of 0. And I'm trying to think of what the derivative was. 1/4 square root of 1/2 x plus 1. What is f primed of 1? 4. Substitute in 0, and you get 1/4. Okay? Interesting. All right, so here's my function. We have 2x squared minus 2 was the original function. What is f of 3? 3 squared is 9, 2, 16. So then I know that g of 16 is how much? 3. Okay, f primed of 3 is equal to 4x, which is 12. G primed of 16 is 1/12. You start to notice this? You figured it out without putting in the actual derivative. So if I calm myself down here, and we say f primed of, let's do -4. Well, first of all, I need to know f of -4. What is f of -4? 16, 32 minus 2 makes? Okay. And then, so whose prime will I be able to find? G primed of 30. And I would know it if I can figure out what f primed of -4 is, which I do know very easily. What is f prime of -4? -16. So what is g primed of 30? 1/-16, so -1/16. That's actually a rule. It is literally a rule. So, g of, I'm thinking, g of 0, going back to the same exact function. If g function's x value is 0, where does that come from in f's function? The y value. So the y value is 0. Right? Problem was there were two of them. I'm going to fill it in and I'm going to tell you I want it at -1. So what is g of 0? -1. What is f primed of -1? -4, because it was 4x, right? Therefore, without any work, I know that g primed of 0 is positive, negative, which one? Oopsie. It's 1 over -4, which makes -1/4, same exact thing. Can someone now say the rule? Right? You have a question? Okay. It is. That's why I said I'm going to pick the -1 value. I had to pick it. It's because the function wasn't 1-to-1, which made the inverse not a function. So what you stated was correct. That's why I picked -1. Okay? If I don't pick it, then yes, you would have two different answers. Okay? Someone give me a rule. Summary. Some way to do all of this tomorrow or tonight for homework. All right. Lottie, start us off. What do you think this rule is saying? So here's usually what people say. This is the problem. If we keep writing x, it has to mean the same x. So you have to define it. You have to start off with something. If I start with f of x equals y, then does it make sense that I can fix this for you? I'm going to tell you right now, everyone hates this rule. It's like the easiest rule in life, and you will have one question on the AP with this rule. It'll either be one multiple choice question, or it'll be a part of a free response question. It is an easy rule, because there's not much work to it, but everyone gets it wrong. Why? Because it's a random rule. It's random. You're not going to use this rule over and over and over and over again, so it's a random rule. So those of you with extremely good memory, get it right. Those of you with not so great memories, always get it wrong. Figure out a system. So tomorrow I'll come in, I'll probably ask what the rule is again. You should be able to describe it, because I think sometimes in words it's a little confusing because of the switching, that switching business. All right? So, there were more notes. I don't really feel like I need to go through all of them. Your homework tonight is to finish number 19. I'm going to give you only a small piece of 20 that relates to these types of problems, so that when you come back tomorrow, we can do a summary one more time to make sure we understand this specific rule. Okay? And then you're just going to keep saying the rule to each other over and over and over and over.